Let's do another grams to grams calculation. This one is involving butane and oxygen. Again, the butane will burn. That's what's in a torch for lighting candles. Okay, plus oxygen will react to make carbon dioxide and water. Okay, and remember the coefficients tell us how many moles are used of each material. Okay, what mass of oxygen, there's our question, what mass of oxygen is needed to completely burn 137.9 grams of butane? Notice I've circled the word oxygen and I've circled the word butane because butane, since I know the number there, that is my given material. The butane number has been given. Butane is the given material. Oxygen is part of the question. I want to know how many grams. So oxygen is the unknown material. Okay, it's important that you know that before you begin. Now, I want to know what mass of oxygen. That's going to mean grams. So we have to know the molar mass of oxygen. But we did that on the previous page. We knew that oxygen, O2, was the mass of oxygen from the periodic table times 2. We got 31.998 grams per mole. That is the molar mass for O2. And again, do not use coefficients to get the mass. That would be wrong. But then we have butane, and I did this calculation earlier today to find butane. Notice that for butane, we have C4H10. If we take 4 carbons and 10 hydrogens, because that's what the formula is, C4H10, you get 58.124. 58.124. Okay, that's the number of grams of butane per mole. So here I've written it down to make it convenient for later. Let's set this aside. Now that we have the molar masses, the calculation and the setup will be much smoother. Okay, I'm going to start with the given. 137.9 grams of butane, which is C4H10. Okay, let's put this over 1. We always put the given over 1 anyway. Now, you know that we do not want grams of butane in our answer. That means we need to cancel it to the bottom of the next column. Grams of butane. Cancel it out, get rid of it. And if we follow the foldable, it also says that when you start with grams, the molar mass of given, or basically the grams of given, will be the next unit, and that's how we'll cancel it. Okay, and when we have grams of given at the bottom here, we'll end up putting moles of given at the top. Moles. And remember that the given material is butane, which is C4H10. Read the questions very carefully. I'll be providing sentences to tell you what material is what when I give you a material you've never had in your class before, like butane here. All right, let's continue forwards. We'll put all the words, all the units down first, and then we'll put in the numbers. Okay, I do not want my answer to be moles of butane. I want mass of oxygen. So that means that moles of butane needs to be canceled out. So moles of butane will get copied down here. Okay, moles of butane. Oh, look at that. Moles is in the bottom for the first time. And when moles is in the bottom for the first time, I have a mole ratio step. Moles of given at bottom, moles of butane, butane's a given. I want moles of unknown. The unknown is oxygen because it was in the question. So moles of oxygen, O2, moles of oxygen is the unknown, moles of unknown on top. Okay, but I don't want the answer to be moles of oxygen. We need to be able to cancel that out. So I'm going to take moles of oxygen and I'll copy it to the bottom of the next column. Yep, we need another column. And so moles of oxygen will go there. Now this is not the first time moles is in the bottom. This is the mole ratio, this is not. What we're doing now is actually converting moles of the unknown to the unit we want it in, which is grams. This time we want what mass of oxygen. So grams of oxygen must go on top, and we will put the molar mass of oxygen here. Notice here it says molar mass unknown, molar mass in grams of the unknown. And we already learned that 31.998 was the molar mass of O2. So I'm using that number here because that's the molar mass of oxygen. Okay, I've got the mole ratio here. Let's do that. Now remember, mole ratio comes from the coefficients. So if we go from oxygen, the coefficient is 13. Okay. 13 from the equation, that's where 13 is coming from. Moles of butane, notice the coefficient is 2. Now these cannot be reduced. If they could have been, I never bother reducing them, but I bet you might reduce them because you're so used to doing it in algebra. That's okay, as long as you do it correctly. All right, so I've got 13 over 2 because that's what the equation tells me to do with oxygen and then with butane. Okay, mole here and mole there. Notice 1 and 1. Okay, 1 mole of unknown is equal to its molar mass. 1 mole of the given is equal to its molar mass. That is why we have 1 here, because 1 mole of oxygen has this many grams of oxygen. And here, 1 mole of butane. Oh, we didn't put the mass in yet, no problem. We'll go to our calculation answer, 58.124. 58.124 grams of butane. That is correct. Now we have all the numbers set up, so I'll point to it as I enter it into my calculator. We have 137.9. I'm skipping the times 1 because if you multiply by 1 it won't change the answer. But I have to multiply by 13. I have to multiply by 31.998. I have to, remember on the bottom we divide, so I'm dividing by 58.124 and I'm dividing by 2 equals, because dividing by 1 there won't make any difference to my answer. Okay, I did not hit the decimal point correctly. Give me one moment. 137.9. There we go. Actually, I hit the 0 instead of the point. Okay, so we get 493. And notice it says 0.45, a whole bunch of stuff. I want 4 significant figures. The given has 4 digits, so I need 4 digits in my answer. Here's the first, here's the second, here's the third. The last one's going to be 4, but we round it up to 5 because the 4 is followed by a 5. So 493.5 grams of oxygen. And you saw me demonstrate that it's important to be able to do reasonableness. When I saw, I'll take it back, when I saw that my answer was 49,055, I knew something was wrong. You should feel comfortable going back up to your work. You see that 0? I accidentally hit the 0 instead of the decimal point. So luckily, I'm able to go back and check my work and fix it and make it have a decimal point where the 0 was. Scientific calculators are wonderful. Okay, so that's how I do yet another grams to grams question.